There's a factory in Casa Grande, Arizona, that processes 1.2 million pounds of corn every single day and turns it into the most addictive snack food on earth. The Doritos production line runs 24 hours a day, 7 days a week, producing 180,000 chips per minute. And the process that transforms plain corn into a chip so engineered for addiction that PepsiCo spent $40 million researching the exact crunch frequency that triggers maximum dopamine release in your brain. What you're about to see is how industrial food science creates a product so optimized for overconsumption that the average American eats 3.6 pounds of Doritos per year without even realizing it. Here's the full process from raw corn to the chip you can't stop eating. It starts with whole kernel corn, but not the corn you eat. This is industrial feed corn that's been genetically selected for maximum starch content. Each kernel is 73% starch by weight, compared to 60% for regular corn. That extra starch is critical because starch is what creates the structure that holds the flavor chemicals you're actually addicted to. The corn arrives in rail cars carrying 200,000 pounds at a time. It gets dumped into giant hoppers and then sent to cooking tanks where something called nixtamalization happens. The corn kernels get cooked at 200 degrees Fahrenheit in a calcium hydroxide solution for 90 minutes. Here's why this matters. The calcium hydroxide is literally lye, the same chemical used to make soap. It breaks down the outer hull of the corn kernel and gelatinizes the starch inside. This process removes the corn flavor almost completely, which is exactly what Frito-Lay wants. They don't want you tasting corn, they want a blank slate that can carry flavor chemicals. After cooking, the corn sits for 12 hours in what's called steep time. The kernels absorb water and swell to triple their original size. The hull loosens and the inside turns into a paste-like consistency. At this point, it barely resembles corn anymore. Gelatinized starch matrix ready to be transformed. The cooked corn moves to washing tanks where jets of water blast off the loosened hulls and the calcium hydroxide solution. Then it goes into industrial stone grinders that are the size of cars. These grinders pulverize the corn into masa, which is the technical term for corn dough. The grinding happens in stages. First grind gets the texture down to coarse meal. Second grind makes it finer. Third grind creates a paste so smooth that individual corn particles are under 100 microns. For reference, that's thinner than human hair. The masa at this point looks like wet concrete and has the consistency of thick cake batter. But here's where it gets engineered. The masa isn't just corn anymore. Frito-Lay adds vegetable oil directly into the grinder at 3% by weight. This pre-fats the masa, so the chips will absorb less oil during frying, which saves money and creates a specific texture. They also add calcium and other minerals to adjust the pH to exactly 6.8, which is the optimal level for the next stage. The masa gets pumped into holding tanks where it's constantly agitated to prevent separation. The temperature is held at exactly 140 degrees Fahrenheit. Too cold, and it thickens. Too hot, and the starches break down further. Everything in this factory is controlled within margins of less than 2 degrees and monitored by computers. The masa flows onto massive sheeting rollers that are 54 inches wide and moving at 60 miles per hour. These rollers squeeze the masa into a continuous sheet that's exactly 1.2 millimeters thick. The tolerance is plus or minus 0.05 millimeters. That precision is critical because chips that are too thick won't cook properly, and chips that are too thin will burn. The sheet moves on a conveyor under an array of cutting dies. These dies are hydraulic stamps that punch out the triangle shapes at a rate of 180,000 per minute. The triangles are isosceles with 60-degree angles at the base, which testing showed is the optimal shape for scooping dips and stacking in bags without excessive breakage. But here's the waste they don't talk about. The cutting process generates scrap masa from the areas between triangles. This accounts for about 18% of the total masa. It gets collected, reground, and fed back into the system. But it can only be recycled once because the starch structure degrades with repeated processing. After that, it's sold as animal feed. The cut triangles drop onto a second conveyor belt that's perforated with thousands of small holes. This is the drying conveyor, and it's moving through an oven that's 40 feet long at exactly 300 degrees Fahrenheit. The chips spend 90 seconds in this oven, and during that time, their moisture content drops from 55% to 25%. They're not cooked yet. This is just moisture removal to prepare them for frying. The partially dried triangles drop into a continuous fryer that's basically a river of vegetable oil flowing at 400 degrees Fahrenheit. The oil is a specific blend of corn, canola, and sunflower oil mixed to have a smoke point of 450 degrees and a specific fatty acid profile. This blend costs Frito-Lay 35 cents more per gallon than generic frying oil but creates a flavor and texture that testing proved consumers prefer. The chips spend exactly 12 seconds in the fryer. The remaining moisture inside the chip flashes to steam and creates thousands of tiny bubbles in the starch matrix. This is what creates the porous structure that makes Doritos simultaneously crunchy and dissolvable in your mouth. The bubbles are engineered to be 20 to 60 microns in diameter through the precise control of moisture content before frying. Here's the chemistry that makes them addictive. During frying, Maillard reactions occur between the amino acids and sugars in the corn. This creates hundreds of flavor compounds including pyrazines, furans, and thiophenes. These are the same compounds that make roasted coffee and grilled meat smell good. Your brain associates these compounds with calorie-dense food and triggers reward responses. But Frito-Lay also controls the rate of oil absorption. The chips are entering the fryer at exactly 25% moisture. As that moisture evacuates, oil fills the voids. The final chip is 28% fat by weight. That exact percentage was determined by 15 years of consumer testing. Lower fat content and people say the chips taste dry. Higher fat and people say they're greasy. 28% is the sweet spot where your brain registers maximum pleasure. The chips exit the fryer and immediately hit a vibrating screen that removes excess oil. Then they move onto a cooling conveyor that drops the temperature from 400 degrees to 180 degrees in 30 seconds using forced air. The rapid cooling sets the structure and prevents the chips from continuing to cook. The plain chips move into the seasoning tumbler, which is a rotating drum that's 30 feet long and 8 feet in diameter. The chips enter at one end and tumble through while the flavoring is applied. But calling it flavoring is like calling a fighter jet a flying machine. What Frito-Lay sprays onto these chips is the result of $40 million in food science research. The nacho cheese flavor, which is the most popular, contains 27 separate ingredients, not including salt. The base is whey protein and cheddar cheese powder, but that's less than 30% of the flavor weight. The rest is what makes Doritos impossible to stop eating. Here's what they don't list clearly on the label, which is pure umami flavor that tricks your tongue into thinking there's more protein than there actually is. Disodium inositol and disodium guanylate, which are flavor enhancers that make the MSG work 15 times more effectively. Your brain lights up the same reward centers that activate when you eat actual meat. Then there's the acids. Citric acid, lactic acid, and malic acid create a sour note that makes your mouth water and triggers more eating. The acidity is set to pH 4.2, which testing showed keeps people reaching for the next chip because their mouth never fully balances. But here's the really engineered part. The flavoring includes autolyzed yeast extract, which is MSG, that doesn't have to be labeled as MSG. It also contains hydrolyzed corn and soy proteins, which are proteins that have been chemically broken down into their amino acid components. These free amino acids hit your taste receptors harder and faster than natural proteins. The flavor powder is electrostatically charged as it's sprayed onto the chips. The chips coming out of the fryer are slightly negatively charged from the oil. The powder is given a positive charge. This makes the powder stick to the chip surface more efficiently. It reduces flavor waste by 15% and creates a more even coating. The entire seasoning system applies exactly 4.8% flavor by weight. That percentage is so optimized that Frito-Lay has a quality control lab that weighs and analyzes chips every 15 minutes to verify the coating weight. If it drifts by more than 0.2%, production stops and the system is recalibrated. After seasoning, the chips move through a final inspection system that's straight out of a sci-fi movie. High-speed cameras photograph every chip at 400 frames per second. Computer vision algorithms analyze each image for color uniformity, size consistency, and defects. Chips with brown spots, irregular shapes, or inconsistent color get hit with precisely aimed air jets that blow them off the line. The rejection rate is 2%, which means 3,600 chips per minute get destroyed. But here's what they're really testing. The crunch. Frito-Lay has a texture analysis lab where chips are compressed in a universal testing machine that measures force required to fracture. The target is 4 pounds of force. This is the exact pressure that, when applied by your teeth, creates a fracture sound at 63 decibels. That specific crunch frequency hits your ear at the same time the flavor hits your tongue and the texture registers in your mouth. This multi-sensory hit creates what food scientists call the bliss point, which is the combination of taste, texture, and sound that maximizes pleasure response. Your brain releases dopamine, you feel satisfaction, and 30 seconds later your blood sugar spikes and then crashes, making you want another chip. The reason Doritos are specifically triangular is because that shape creates 3 distinct fracture points when you bite down. Your front teeth hit the tip, creating the first crack. Your molars hit the base edges, creating 2 more cracks. 3 fracture sounds in rapid succession create a more complex auditory response than a single crack. This was proven in testing to make people rate the chips as 18% crunchier than round chips with identical texture. The approved chips move to the bagging line where they drop into bags at exactly 9.75 ounces for a standard bag. But the bag isn't just filled with chips. It's filled with nitrogen gas that's been precisely mixed to be 99.5% pure nitrogen and 0.5% oxygen. This mixture prevents the chips from going stale and oxidizing, which would create off flavors. The bags are filled to exactly 40% capacity by volume. The remaining 60% is nitrogen gas. And people complain about it constantly, but that air serves 3 purposes. It cushions the chips during transport and prevents them from being crushed into dust. It creates a pressure differential that keeps the bag inflated on shelves, which makes it more visible and appealing. And it prevents oxygen contact that would make the chips stale in days instead of weeks. But here's what really matters about the packaging. The bag material is a 7-layer laminate designed by chemical engineers. It includes layers of polyester for strength, aluminum for light blocking, and specialized polymers for sealing. This bag costs 8 cents to manufacture compared to 2 cents for a basic plastic bag. Frito-Lay spends the extra money because that barrier keeps the chips fresh for 90 days instead of 14. The sealed bags get printed with batch codes and expiration dates using inkjet printers that fire 50,000 drops per second. Then they move through metal detectors that would identify any metal contamination from the machinery. Finally, they go through weight checkers that verify each bag is within 0.5 ounces of target weight. Any deviation and the bag gets rejected. Here's what makes Doritos different from regular chips. Regular tortilla chips are corn, oil, and salt. Oil, salt, and 27 ingredients engineered to trigger specific neurological responses. The combination of MSG, acids, fats, and engineered crunch creates something that food scientists call hyperpalatability. Hyperpalatable foods are engineered to be more rewarding than natural foods. Your brain evolved to seek out calorie-dense foods because calories meant survival, but natural foods have self-limiting factors. You get full from protein. You get sick from too much fat. You get tooth pain from too much sugar. Hyperpalatable foods hack around these limits. Doritos specifically hit 3 targets simultaneously. They're fatty enough to trigger calorie sensors in your gut, but not fatty enough to make you feel full. They're salty enough to make you thirsty and keep reaching for more, but not so salty that you stop eating. And they're flavored intensely enough to be exciting, but designed to dissipate quickly, so you need another hit. The vanishing caloric density is the key mechanism. Each Doritos chip dissolves in your mouth in about 20 seconds. Your brain registers the flavor and texture hit, but because it melts away so fast, your satiety signals don't trigger. Your brain thinks you haven't eaten anything substantial, so you keep eating. This is why you can consume 1,000 calories of Doritos and still be hungry. The Casa Grande factory produces 500 million pounds of Doritos per year. That's enough chips to give every human on Earth 15 chips. Americans eat $1.7 billion worth of Doritos annually. The average American household buys Doritos 4.2 times per year. And none of this is an accident. It's not that Doritos happen to be tasty. It's that 800 food scientists and chemical engineers spent $40 million figuring out how to make a chip that your brain can't resist. The corn is genetically selected. The thickness is calculated. The fry time is optimized. The crunch is engineered. The flavor is chemically designed. The bag is scientifically constructed. You're not eating a corn chip. You're eating the culmination of industrial food engineering designed to maximize consumption. The factory in Casa Grande doesn't make snacks. It makes neurology-optimized calorie delivery devices that happen to taste like cheese. That's why the bag is always empty before you mean to finish it. Because finishing it is exactly what it was engineered to make you do.